Okay, now we'll start with the Thevenin's theorem. First, let's clarify some terms. So, RL means load resistance. Okay? Load resistance. RL basically means whatever resistance you will be performing the Thevenin's theorem for. So usually it will be marked in the question. This entire blue part is where you will be applying the Thevenin's theorem, and this RL is the load resistance, which you will not touch. It will not be included in the Thevenin's theorem. And similarly here, so this entire circuit has been simplified into this, but as you can see, this RL has remained the same. So that is the load resistance. Now RTH is Thevenin's resistance. Thevenin's resistance. This is the resistance we will calculate after removing all the sources. ETH is Thevenin's voltage. Thevenin's voltage. So this is the Thevenin's equivalent voltage actually. So this is the equivalent voltage that we will calculate after completing the Thevenin's theorem. So this is the normal. This is the normal voltage, and this is the Thevenin's voltage of this circuit, simplified version. And Thevenin's equivalent circuit is basically this circuit. The circuit you get after applying the simple circuit of a voltage, Thevenin's resistance, and the load resistance all in series. This is the circuit you get after applying the Thevenin's theorem in a more complex circuit. Now that those terms are clear, remember the terms and what they mean. Now let's go into the steps of the Thevenin's theorem. So step 1 is to remove the load resistor. Let's do it along with a question. Okay, so we have a circuit given, and this is clearly mentioned as the load resistance, this RL, the last one. So what's step 1? Step 1 is to remove the load resistor RL, the part of the circuit where you need to calculate Thevenin's equivalent circuit. So this RL, we'll remove it. Okay, let's redraw the circuit. Redraw it without the load resistance. So removing the load resistance means there will be an open circuit. Now step 2 is to remove all the sources. So let's redraw this again. Let's write this step 1. Now step 2 will be to remove all the sources. So there's only one source in this circuit, the voltage source. So it'll become a short circuit. Okay, and then an open circuit as it was. Okay, so now step 3 is to calculate the Thevenin's resistance RTH. From this redrawn circuit in number 2, we will the resistance we calculate will be the Thevenin's equivalent resistance, or RTH. And we have to start from this side, the side of the load resistance. Okay, so we start from here, and we can see that this resistance and this, they're in parallel. So the values were 6 ohm here and 3 ohms here. Okay, so what's RTH? RTH is equal to 3 parallel 6. That means 1 over 3 plus 1 over 6 to the power minus 1. And that equals to 1 over 3 plus 1 over 6 to the power minus 1. So 2. RTH is 2 ohms. That's the Thevenin's resistance. Now that is one step of our solution already done. Now let's go to step 4. So replace all the sources in their original positions and calculate total resistance. So basically we will again redraw this circuit. Now we have the sources in place, right? So sources is 9 volts here, and this was 3 ohm, and this is 6 ohm. Now we have to find the normal equivalent resistance, or RT. This time not from here, it will be from the source, voltage source. So now we can see that 3 and 6 are actually in series. This is an open circuit here, so no current flow. And 3 and 6 are in series. So RT is equal to 3 plus 6, so 9 ohms. That's RT. Now step 5. Calculate Thevenin's voltage ETH for the terminals where the load resistor RL was situated. Okay. So basically, now again come back to the original circuit. We have to find the voltage across here. This is the load resistance, and the voltage across the load resistance is the Thevenin's voltage. Okay. So we have to find the voltage across this RL. Now notice that the 6 ohm and RL, they're in parallel, right? So the voltage across 6 ohm and the voltage across RL will be the same. So we can just find the voltage across 6 ohm using voltage divider rule, and that will be our ETH, or Thevenin's voltage. Okay, let's apply the voltage divider rule. So we know the voltage divider rule is, we have to find the voltage for 6 ohm. That will be ETH, right? So let's write VR2 is equal to E total voltage over total resistance, so RT, times the resistance we want to find the voltage for, so R2. That's the voltage divider rule. Now what's the total voltage? 9 volts. 9 volt over RT is 9 ohm times R2, which is 6 ohm. 6 ohm. Therefore VR2 means ETH, right? So E Thevenin's is equal to 6 volt. 9 is 1, so 6 volt. So we have ETH, we have RTH. Now we have to draw the Thevenin's equivalent circuit. How do we do that? First we put a voltage source. Okay, plus, minus. And now the value of this voltage source will denote it as ETH, and its value will be the one we find here. So 6 volt. 6 volts. Then we will draw a resistance in series to it. This will be RTH. And what was RTH? We calculated it to be here 2 ohms. So RTH is 2 ohms. And we will have another resistance down here. This will be RL. It doesn't need a value. You just need the value of ETH and RTH. And this is the Thevenin's equivalent circuit, the final answer. Now let's do another one. So here we have a current source. Now again, step 1 is to remove the sources. Step 1 is to remove the load resistance. So you keep the sources, then draw the resistors as they are. But no load resistance. So open circuit. Okay. Now step 2 is to remove the sources. So when you remove a current source, you will get an open circuit again. So here you go, open circuit. Then we have a resistor here, and another resistor here, and then again open circuit. Okay. Now we have to calculate RTH. For calculating RTH, again we have to start from this side, the side of the load resistance. So from this side, if we look at the resistors, they are in series. There's only one common point, the others are disconnected. So the Thevenin's resistance will be RTH is equal to this will be 2 and 4, so 2 ohms plus 4 ohms, we have 6 ohms Thevenin's resistance. Now step 3 is to replace the sources. So basically go back to step 1, the figure you drew in step 1, and here we will find RT, the total resistance. So this time it starts from here. Okay, actually for this circuit we don't need to find RT because this is a current source, and we have to find the voltage of this 4 ohm resistor, right? This is our load resistor, so Thevenin's resistance will be across this. And when we have the circuit here, there's an open circuit, so no current is flowing through here, right? No current. Also no current flowing through this one. So the last resistor we have here is this one, our 4 ohms. There is current flowing through this. So the voltage across this will be the Thevenin's voltage, ETH. And to find that, we can simply just do ETH is equal to V is equal to IR, Ohm's law. So E basically means V, so I and R means R1. So what's I? The source is 12 amperes times R1 is 4 ohms. So we have 48 volts. That is the Thevenin's, that is a terrible 8. 48 volts, that is the Thevenin's voltage. So we have RTH, we have ETH. So that's it. Now we can draw the Thevenin's equivalent circuit. Okay, so for the Thevenin's equivalent circuit, first we draw a voltage source, denote it as ETH, and put the value of ETH, which is 48 volts. So 48 volts, and then we draw a resistor in series, another resistor in series, and then close the circuit. And this first resistor is RTH, the Thevenin's resistance, which we calculated to be 6 ohms. 6 ohms. And this one is the RL. You don't have to put its value, but we had its value here. We can put it if we want, so 7 ohms. 7 ohms. So that's it. That is the final answer, the Thevenin's equivalent circuit. Now here are some more practice questions for you to do. Pause the video and try to solve them. And here's another one. They're all the same. You just have to apply the same steps. Just follow this page, apply these steps, and they're all the same, more or less. They just look different. Let me know in the comment section if you need the answers to these questions.